Hi, once again, welcome to Varenya's Photon Online Educational Academy. This is Guntuka Srinivas. This channel is a free educational channel meant for IIT and NEET examinations. This channel deals with the basic fundamental aspects associated with the physics, chemistry, and mathematics subjects related to IIT and NEET examinations. I welcome you all for the IIT chemistry classes. In this session, let us see some of the basic things associated with the mole constant. In the previous session, we have seen the introductory part of the mole concept. Let me take up some more things related to mole. In the previous class, it has been asked that the question was given as what is the mass of 1 mole of carbon atom? The question was asked that the mass of 1 mole of the carbon atom is how much? To calculate this, let us see the carbon atom. Atomic number of carbon elements, that is 6. Atomic number of carbon is 6. Hence, it consists of, there are 6 protons, 6 neutrons, and 6 electrons. Observe here, there are 6 protons, 6 neutrons, and the 6 electrons in the carbon atom. Clear? Now let us see. This is carbon atom structure. This is the nucleus. This is nucleus. This is the orbit. So I clearly write, this is nucleus. This is orbit. Clear? Now, in the nucleus, there are protons. So 6 protons and 6 neutrons. 6 protons and 6 neutrons. And around the nucleus, in the orbit, this is the orbit, around the nucleus, electrons are negatively charged, and these electrons are moving in the orbit. All these are the electrons. How many electrons are there? 1, 2, 3, 4, 5, 6. 6 electrons are moving around the nucleus. Inside the nucleus, 6 protons, 6 neutrons are present. You know very well. Protons are positively charged, electrons are negatively charged. Clear? Now, observe here. I need the mass of the carbon atom. First, I am concentrating on the mass of carbon atom. Clear? Now, observe it. Mass of carbon atom. One atom of carbon. For the one atom of carbon, I require the mass. We take the mass completely, the core area. Core area is the central area nucleus. So, what are the things that are existing in the nucleus? In the nucleus, there are 6 protons and the 6 neutrons. So, hence, the 6 into mass of, M stands for mass of proton, 6 protons are existing. So, mass of 6 protons plus, how many neutrons are existing? 6. 6 into mass of each neutron, Mn. M stands for mass, N stands for neutron. There are 6 protons and 6 neutrons in the nucleus. Hence, the total mass of carbon atom is mass of 6 protons plus mass of 6 neutrons. Clear? Mass of 6 protons and mass of 6 neutrons. Now, observe mass of proton 1.67 into 10 to the power of minus 24 grams. Earlier we have seen G for grams plus mass of 6 neutrons, 6 into mass of neutron, almost all we are taking equal to the mass of proton for all calculation purpose. We have seen the earlier session. So that is also see 1.67 into 10 to the power of minus 24 grams. So G stands for gram. 6 mass of 6 into mass of 6 into mass of proton, 6 into mass of neutron. Clear? Both are equal values. Always, for all calculation purposes, mass of proton is taken equal to the mass of neutron. Clear? Generally, mass of neutron is slightly more than the mass of the proton. But calculations, we assume both are equal. Now, this is 6 into this one and 6 into this one. Clear? Now observe. If I take 6, this entire 1.67 into 10 to the power of minus 24 is known as 1 atomic mass unit. That is known as 1 atomic mass unit. So 6 into 1 AMU, 1 atomic mass unit, plus 6 into, this is also 1 atomic mass unit, 6A, 1A. So mass of proton is also known as the 1 atomic mass unit. So 6 into 1 AMU plus 6 into 1A. Clear? Now completely, if I take mass of 1 carbon atom is equal to, if I add those 6 AMU, completely 12 AMU, 12 atomic mass units. Mass of 1 carbon atom is equal to 12 atomic mass units. Is it clear first? 12 atomic mass units. In the previous session, we have also seen that in the reverse, if I write, one atomic mass unit can also be expressed in terms of the mass of one carbon atom is 1 by 12 of mass of one by 12th of mass of one carbon atom. Mass of one carbon. Observe carefully. Okay. Mass of one carbon atom is 12 atomic mass units. Previous calculation. Reverse, if I want to express 1 AMU is equal to 1 by 12th of mass of one carbon atom. You can express like this also. Clear? No. Observe. Now, what is the question? Question was clear. The question was that mass of one mole of carbon, 1 mole of carbon atom is equal to how much? 1 mole of carbon atom is equal to how much? Okay, you know very well that 1 mole is equal to how much quantity? Avogadro number 6.022 into 10 to the power of 23. That means this much quantity is equal to 1. That means 1 mole. That means here 1 mole of carbon atoms means mass of Avogadro number of carbon atoms. Mass of Avogadro number of carbon atoms. Clear? Now I am writing clear. Okay. 1 mass of 1 carbon atom is equal to, just now we have seen 12 atomic mass units. Simply have clarity. Mass of one carbon atom is 12 AMU, atomic mass unit. Clear? Mass of one carbon atom is 12 AMU. Now, 1 carbon atom is 12 AMU. 1 mole consists of how many atoms? Avogadro number of atoms. So 6 mass of 6.022 into 10 to the power of 23 atoms of carbon is equal to how much? 1 mole. Since 1 mole consists of Avogadro number of atoms, so many quantity of atoms. So mass of 6.022 in 10 to the power of 23 atoms of carbon is how much? Just simply cross multiply this. That is equal to 6.022 into 10 to the power of 23 into 12 AM. 12 AM. This is 1 mole of carbon atoms mass. Okay. Now let us simplify further. Okay. That is 6.022 into 10 to the power of 23 into 12 AMU. Clear? 12 AMU. So 6.02 into 10 to the power of 23 into 12. 1 AMU. 1 AMU is equal to how much? Mass of proton 1.67 into 10 to the power of minus 24 grams. To the power of minus 24 grams. Now observe this quantity. This quantity, if we multiply, it becomes 1. Then final answer will be, it becomes 12 grams. Becomes 12 grams. That means final conclusion, if I write, 1 mole of 1 mole of carbon atom is equal to 12 grams. Mass of, here clearly write, mass of 1 mole of carbon atom is equal to 12 grams. 12 grams. Okay. This 1 mole of, always underline the word, 1 mole of mass of any atom. I am generalizing. Here it is with respect to carbon atom. But I am generalizing. 1 mole of carbon atom is 12 grams. Here, suppose if I take nitrogen atom. Nitrogen atomic mass is 14 am. 1 mole of nitrogen atom is equal to 14 grams. Now I am generalizing. 1 mole of any element atom is equal to, that is known as gram atomic mass. In simple, it is known as GAM, gram atomic mass. Clear? Gram atomic mass. So I clearly write 1 mole of 1 mole of carbon atom is equal to 12 grams. This is known as gram atomic mass. And this is also known as molar mass. It is a general term used. Molar mass. Molar mass means it consists of 1 mole, mass of 1 mole of atoms. Mass of 1 mole of atoms. Here afterwards, gram atomic mass is also known as the molar mass. Molar mass means mass of 1 mole of atoms. Okay, if I write the definition of molar mass is equal to, molar mass is equal to mass of 1 mole of atoms. Mass of 1 mole of. Observe, 1 mole consists of how many quantity? Avogadro number. 6.022 into 10 to the power of 23. So indirectly, I can also write mass of 6.0022 into 10 to the power of 23. Quantity of atoms. Clear? Mass of 6.022 into 10 to the power 23 of atoms is known as molar mass. We can also write like this. Mass of. This quantity is known as Avogadro number. Mass of Avogadro number of atoms. Avogadro number of atoms. Observe carefully. Molar mass is also known as mass of 1 mole of atoms of any element. I am generalizing. Or 1 mole means Avogadro number of atoms. 1 mole Avogadro number means 6.022 into 10 to the power of 23 atoms. Is it clear? So here afterwards, gram atomic mass is also known as molar mass. Gram atomic mass is also known as molar mass, means 1 mole of mass of 1 mole of atoms. Is it clear? Right? Observe carefully. Let me take up a simple question on this. That is, here I write the question. Find the number of moles of oxygen atoms in 80 grams of oxygen. 80 grams of oxygen. Observe. Find the number of moles of oxygen atoms in the 80 grams. I'm highlighting 80 grams of oxygen. Okay, we need number of moles present in the 80 grams of oxygen. Clear? Okay. Now, observe. Just recollect the previous things. We have also seen the oxygen atom. Okay. We know that. Okay. 1 mole of oxygen atom. 1 mole of oxygen atom. That means atomic mass of 1 mole of oxygen. Atomic mass of 1 mole of oxygen. How much? Earlier we have calculated 16 grams. 16 grams. 1 mole of oxygen atom. Here, 16 grams. That means this 16 grams is what? Gram atomic mass. This 16 grams is what? Gram atomic mass. This is gram atomic mass. Or this is also known as what? Molar mass. Molar mass. This 16 grams is also known as gram atomic mass or molar mass. Clear? Now I write reverse. Clear? 16 grams of oxygen atom. 16 grams of oxygen. 16 grams of oxygen atoms is equal to 1 mole. Okay? Simple. 1 mole of oxygen atom is equal to 16 grams. 1 mole of the mass of 1 mole of oxygen atom is equal to 16 grams. Earlier we have seen. Now the statement I am reversing. 16 grams of mass of 16 grams of oxygen atoms is equal to 1. Because in the question he has asked how many moles are present. That's why I am reversing the statement. So 16 grams of oxygen atoms, that entire 16 grams of mass of the entire 16 grams mass of oxygen atom is equal to 1. Now, in the given statement, how many grams are given? How many grams are given? In 80 grams of oxygen, in the 80 grams of oxygen, how many moles are present? In 16 grams, here I write, in 16 grams of oxygen, 1 mole, that is equal to 1 mole equivalent. In 80 grams, it is given. In a question, it is given in 80 grams of oxygen, how many moles are required? How many moles are present? Just cross multiply this. That is equal to 1 mole, 1 into 16 grams by 1 mole, 1 mole into cross multiply this. 1 mole into 80 grams by 16 grams. So grams will go. Clear? 16 fives, 16 fives. So 5 moles are present. 5 moles are present. Okay. 16 grams of oxygen mass equivalent to 1 mole. The question itself is asked in 80 grams of oxygen, that will be equivalent to how many moles? So in 16 grams, if it is 1 mole, in the 80 grams, how many moles? Just cross multiply, divide by 16. It will give the 5 moles. Number of moles present in the 80 grams of oxygen is 5 moles. Is it clear? A simple question. Okay. Now, here afterwards, I generalize one formula. Observe. Here afterwards, I generalize one formula. That is, observe, what we have done to calculate the number of moles. Here I am putting number of moles because answer is number of moles. So number of moles, calculate number of moles. Okay. Now what we have done? We have taken the given mass. In the question, it is a given mass. So given mass. The question, it is given mass by 16 grams. 16 grams is denominator. What is denominator 16 grams? Gram atomic mass. GAM, gram atomic mass. Or this is also known as molar mass. Molar mass. Okay. That means year afterwards, to find out number of moles, direct to formula is given mass by the gram atomic mass or molar mass. This is the formula. So number of moles is equal to that is number of moles is equal to given mass by the gram atomic mass or the molar mass. Okay. Now I apply the same formula to this question. Observe. What was the question given? The question given is that. Observe. Question given is find. Same question I am taking. Find number of moles of oxygen atoms in 80 grams of oxygen. 80 grams of oxygen. That was the question. Okay. Now I am making use of the formula. What is the formula? Direct attack, I am using the formula. Number of moles is equal to given mass by gram atomic mass or molar mass. Given mass is how much? Given mass is 80 grams. So 80 grams. The gram atomic mass is how much? Oxygen gram atomic mass. We should by heart all these things. Gram atomic mass 16 grams. Clear? 16 grams. So this if I 5 moles. Is it clear? Let us take some problems. Let me take up some problems. Here, I am taking exercise Exercise 1. Not example, exercise 1. Find number of moles of atoms present in 42 grams of nitrogen atom. 42 grams of nitrogen atom. Clear? Indirectly, in 42 grams of nitrogen atoms, the quantity is nitrogen atom is how many? In 42 grams of nitrogen atoms, 42 grams of nitrogen atoms. Yeah. How many moles are present? Okay. How many moles of atoms are present? That means number of moles are required in 42 grams of nitrogen atom. Let us use the formula directly. Let us use the formula. What is the formula? Number of moles is equal to given mass by gram atomic mass, or simply this is also known as molar mass. Okay, here I am writing R mass. Molar mass means mass of 1 mole of. Clear? Okay. Now, observe. Given mass. How much nitrogen grams are given? 42 grams. Gram atomic mass of nitrogen or molar mass, 1 mole of nitrogen atom. Observe. The atomic number of nitrogen is 7. I'm clearly explaining. Listen. The atomic number of nitrogen is 7. Means it has 7 protons and 7 neutrons in the nucleus. And in the around the nucleus, 7 electrons are revolving. So mass of nitrogen, we are taking only the mass of protons, mass of neutrons. Hence, mass of nitrogen, atomic mass of nitrogen is 7 protons are present, 7 neutrons are present in the nucleus. So mass of 7 protons plus mass of 7 neutrons. So mass of proton, mass of neutron, we are taking as 1 atomic mass unit. Hence, total atomic mass of nitrogen is 7 plus 7, 14 atomic mass units. Atomic mass of nitrogen is 14 atomic mass units. We require 1 mole of nitrogen atom. That means molar mass we require. That means Avogadro number of quantity of the mass we require. We simplify, that comes around the molar mass of nitrogen or gram atomic mass of nitrogen is 14 grams. So here 14 grams. You have to by heart all these things perfectly, then easily you will get the answer. 14, 3 moles. 3 moles are present. The given 42 grams of nitrogen atoms, 3 moles are present. Clear? No, observe carefully. Let me take another question. Clear? Another question. Find number of moles of atoms, number of moles of atoms present in 64 grams of sulfur atoms. Sulfur atoms. This is the question. Find the number of moles of atoms present in the 64. Given mass is of 64 grams of sulfur atoms. Sulfur is denoted by S. Letter is S. You know very well. Clear? Now, apply the formula. Direct attack formula. Number of moles is equal to given mass by molar mass of sulfur atom. Molar mass of sulfur, S, or simply gram atomic mass. Okay, given mass is how much? 64 grams. This is 64 grams. Molar mass of sulfur, 32 grams. So, if I simplify this, 2 moles. The given 64 grams of sulfur atoms, those will be equal to 2 moles. Yeah. Observe carefully. Sulfur is having the 32 grams of the molar mass. Is it clear? So you have to be very careful about these. Let me take up the another question. Clear? The third one. Find number of moles of atoms present in 12 grams of hydrogen atoms. That was the question. Number of moles of present in 12 grams. Given is 12 grams of hydrogen atom. So simply, if we use the formula, number of moles is equal to given mass by gram atomic mass. Simply, in short form, GAM, gram atomic mass of hydrogen atom. Because he is asking in the hydrogen, gram atomic mass of hydrogen. Clear? Now, observe. Given mass, how much of mass is given? 12 grams. He is asking number of moles in 12 grams. So 12 grams given mass by gram atomic mass of hydrogen. Hydrogen atom is atomic number is 1. So in the complete atomic number is 1. So you have the gram atomic mass as the 1 mole of hydrogen atoms is having 1 mole of hydrogen atom is having 1 gram. So that is the gram atomic mass. So 1 gram. So if gram cancels, so it will become 12 number of moles. 12 number of. So this is the simplest way to calculate the number of moles present in the number of moles present in the given quantity. Okay, right? So molar mass is nothing but mass of 1 mole of atoms of an element, or simply mass of Avogadro number of atoms of an element. Clear, right? Now, let me discuss another question, that is the fourth question is one. Okay. What is the mass of one mole of nitrogen molecule into molecule? Nitrogen molecule into molecule. N stands for nitrogen molecule. What is the mass of 1 mole of nitrogen molecule? Now observe, it is a molecule. Here it is a molecule. So observe, one N2 molecule nitrogen. N2 stands for nitrogen. Nitrogen molecule consists of how many atoms? 2 atoms of nitrogen is equal to 2 atoms of nitrogen. One molecule of N2 is equal to, it is consisting of, just observe here, N2. So 2 atoms. Here we have 2 atoms of nitrogen is equal to 1 nitrogen molecule. Here, now observe. Now I generalize the statement. Mass of 1 N2 molecule, mass of 1 N2 molecule, nitrogen molecule, is equal to mass of 2 atoms of nitrogen. Mass of 2 atoms of nitrogen. Clear? Mass of 1 nitrogen molecule is equal to mass of 2 atoms of nitrogen, because 1 molecule of nitrogen consists of 2 atoms. So mass of 2 atoms of nitrogen is equal to mass of 1 nitrogen molecule. Clear? No. Observe carefully. Observe carefully. What is the mass of 1 nitrogen atom? Mass of 1 nitrogen atom. Mass of 1 nitrogen atom is equal to how much? Mass of 1 nitrogen atom. Nitrogen atomic number 7. That it has 7 protons, 7 neutrons. Complete. The entire mass becomes 14. 14 atomic mass units. 14 atomic mass. 1 nitrogen atom. Okay, 14 atomic mass units. Clear? Now, nitrogen, it is nitrogen atom. Mass of nitrogen, 1 nitrogen atom is, that is 14 AMU, atomic mass units. But we require molecule. We require molecule. Mass of 1 N2 molecule, nitrogen molecule, is equal to, consists of 2 times the mass of nitrogen atoms, because it is having the 2 atoms. So 2 times the mass of nitrogen atom. So 2 into 14 AM. That is 28 atomic mass units. 28 atomic mass units. Here, mass of one nitrogen molecule is 28 atomic mass units. Now, one nitrogen molecule is having 28 atomic mass units. Is it clear? So we want 1 mole. We require 1 mole. 1 mole of 1 mole of N2 molecules is equal to mass of 1 mole of N2 molecules. 1 mole consists of how many quantity? Avogadro number of quantity. That means mass of 6.022 into 10 to the power of 23 quantities of N2 molecules is equal to how much? How the clarity in the statement? Mass of one nitrogen atom is 14 atomic mass units. But here we are concentrating on the molecule of nitrogen. One molecule of nitrogen consists of 2 atoms of nitrogen. Mass of one atom of nitrogen is 14. So 2 atoms mass is 2 into 14. So 28 atomic mass units is the complete mass of one nitrogen molecule. But that is only one molecule of nitrogen is 28 AMU, atomic mass units. We require 1 mole. 1 mole consists of how many quantities? Avogadro number of quantities. Those many quantities mass is how much? Clear? Now I am writing the statement in clear. Okay. So mass of okay, 1 into molecule is equal to 14 AMU. So mass of 1 mole. 1 mole is 6.00022 in 10 to the power of 23 quantities of N2 molecules. N2 molecules is equal to how much? Mass is how much? Just simply cross multiply this. As many quantities mass is just cross multiply. Then it becomes 6.022 into 10 to the power of 23 into 14 AMU. Okay. 6.022 into 10 to the power of 23. 14. 1 AM is equal to mass of proton. So 1.67 into 10 to the power of 20 minus 24 grams. So this entire thing, this and this put together 1, it becomes 1. Then finally 14 grams. So 1 mass of 1 mole of N2 molecule equal to 14 grams. 14 grams. And this is known as, since it is the mass of molecule, it is known as gram molecular mass. Gram molecular mass. That is known as GMM in short form. So here we are concerned with the molecule. So complete molecule mass is known as gram molecule mass. Observe carefully the statement. The statement here is, it is molecule. That's why we have used molecule term. It is expressed in the gram. That's why gram. It is the mass of molecule. So mass. So gram molecular mass, GMM. This is also known as molar mass. Earlier we have said that gram atomic mass also molar mass. This is gram molecular mass, also known as molar mass. What is the meaning of molar mass? 1 mole of either 1 mole of either 1 mole of atoms of certain element or 1 mole of molecules is also known as molar mass. So this is also known as molar mass. Be careful about the definition of the molar mass. Be careful about the definition of the molar mass. Molar mass is simply we are using one mass of 1 molar. Either it may be atom or it may be molecule. If the term is associated with the atom, then it is known as gram atomic mass. If the term is associated with the molecule, then it is known as gram molecular mass. Whether it is gram atomic mass or whether it is gram molecular mass, both are expressed as molar mass only. Since molar mass is 1 mole of 1 mole quantity, mass of 1 mole quantity. Is it clear? Right? So this is the molecule association. Okay. Now let me take up a simple question on this. Simple question on this. Okay. Find number of moles. Find number of moles of oxygen molecules. Term is associated with molecule. So find number of moles of oxygen molecules in 64 grams of 64 grams of oxygen O2 gas. O2 gas. Have the clarity clear. Find the number of moles of oxygen molecules. He is specially using the term molecules. So wherever molecules is there, we should use gram molecular mass. In 64 grams of oxygen, given mass is how much? 64 grams of oxygen gas. Clear? Now, let us solve this in the two way. Observe. 1 mole of oxygen molecule. Okay, here I clear like mass of 1 mole of oxygen molecule. Okay, if you calculate oxygen O2 is having 2 oxygen atoms. O2 molecule is having 2 oxygen atoms. Atomic mass of 1 oxygen atom is 16 grams. So complete 1 molecule of oxygen atom, O2, is having 2 atoms of oxygen. So 2 into 1 atom of oxygen is 16 grams. So it becomes 32 grams. 32 grams of the gram molecular mass. This is known as gram molecular mass. In the bracket I am writing GMM, gram molecular mass, or simply mole. Since it is expressed in the mole, molar mass. Clear? Now he wants us in 64 grams of oxygen gas is how much? In 64 grams of oxygen gas is how much? Clear? Now, to calculate this, I am reversing the statement. Observe, 32 grams of oxygen molecules, this much quantity, 32 grams of oxygen molecules, oxygen molecules becomes equal to how much? 1 mole becomes equal to 1 mole. Reversing, I have stated. I'm reversing the state. Then given is how much? 64 grams of oxygen. Yes, consists of oxygen means O2. O2 is a molecule. Consists of how much? Just cross multiply this. 64 into 1 divided by 30. Okay? 64 grams by 30. This becomes 2 moles. 2 moles. 64 grams of oxygen gas consists of 2 moles. Okay. Now I am generalizing. I am establishing one formula here. I am establishing one formula. Number of moles year afterwards is equal to given mass divided by gram molecular mass or molar mass Observe carefully. Gram molecular mass or molar mass. Clear? Wherever molecule associated, we are using in place of molar mass, gram molecular mass. Wherever atoms are associated, in place of molar mass, we are using gram atomic mass. Earlier also, we have used the same formula to calculate the number of moles in the given atom. Numerator is not changed, but denominator there it was gram atomic mass, since atom was used. Here, molecules are used. That's why denominator is in place of molar mass, gram molecular mass. They are used. Is it clear? This is the generalized formula. General formula. Be careful. The general formula. Okay. Here afterwards, number of moles is equal to given mass divided by gram molecular mass. The term is associated with the molecule. Or simply molar. Gram molecular mass also known as molar mass. Okay. Same problem I am explaining by this method. Okay. He was asking just the given mass was how much? That is, here I am putting for the same number of same question. Number of moles is equal to given mass by GMM, gram molecular mass, or molar mass. What was given mass? 64 grams of oxygen. 64 grams of oxygen. What was the gram molecular mass of oxygen? 32 grams. So simply one step answer, 2 moles. 2 moles. That was simply 2 moles. Is it clear? Hope you have understood. Is it clear? Okay. Is it clear? Okay. Let us take up another question. Fine. Number of atoms of carbon. Carbon is in the bracket I have C letter. Carbon present in 36 grams of carbon. In 36 grams of carbon. Observe, find number of atoms of carbon present in the 36 grams of carbon. 36 grams of carbon. Is it clear? He requires in the total quantity 36 grams of carbon consists of how many atoms? Okay. No, just let us use the previous statements. First, let us calculate how many moles are present in this. Okay. Let us calculate. First statement is how many moles are present. So, number of moles in this 36 grams, how many moles are present? Number of moles is equal to given mass, right? Since his atoms is asking, so atomic mass we have to use in the denominator, GAM, gram atomic mass, is also known as molar mass. That is equal to, given mass is how much? 36 grams. And molar mass of carbon atom is 12 grams. Okay, we have seen already. So this becomes, the number of moles present are 3 moles. So in this 36 grams, number of moles present are 3 moles. Observe carefully. We have calculated only the number of moles. So 36 grams, 3 moles are present. But we know that okay, 1 mole of carbon, C stands for carbon. 1 mole of carbon atoms is equal to how much quantity of atoms it is having? 6. Avogadro number 6.22, 6.022, 10 to the power of 23 atoms. So many units in 1. Okay. In 1 mole of carbon atoms, we have so many number of Avogadro number of atoms. But in the given quantity of 36 grams, how many moles are present? 3 moles. So in 3 moles of carbon atoms, how much atoms are present? Just simply cross multiply this. So 6.022 into 10 to the power of 23 multiplied with 3. So many atoms. Okay. This multiplied with this. So many atoms. Is it clear? What we have done in this? In the given 36 grams of carbon atom, we have calculated, first step was we calculated the number of moles. In the second step, we know that 1 mole of carbon atom is equal to Avogadro number of quantities of atoms. So in the given quantity, there are 3 moles are present. In the 3 moles of carbon atom, how much quantity are there? Simply Avogadro number multiplied with 3 moles. That is so many atoms. Is it clear? Okay. Hope you have understood the questions. Be careful that these questions require some practice because mole, gram atomic mass, gram molecular mass, molar mass, all these are somewhat confusing. If you do not practice, you will get simply in confusion. So, what you do is, you go through once again the video and identify the difference between molar mass, gram atomic mass, gram molecular mass, and 1 mole is equal to Avogadro number. Just practice them. As many problems as if you practice, then you will have a clarity about the answer. Is it clear? Hope you have understood the lecture. Follow it. Clear? If you like the channel, finally, what I say is share it and subscribe the channel. You will get series of lectures in the subjects which are required for the preparation for IIT and NEET examinations. Initially, we are concentrating on the fundamental aspects, hence we are slow. Later, we will go in the advanced levels of topics. Thank you very much.